example number 3, we need to identify the unknown forces. So there are two forces that are unknown in this case, F3 and F2. What we have is just F1. Uh, However, the key of answering this particular problem is also uh, trying to draw the free body diagram at first. So that should be the first thing that you need to do. So if I'm gonna do the free body diagram, all the forces are acting on the box. Okay, so my object here is the box. So I'm gonna place the dot on my box. Well, I have F1 that is downward, so that should be that particular force. It's given as 50 newtons. The magnitude is 50 newtons. And then I have here F3, but F3 is not straight. It's somehow angled off with the horizontal upward at 60 degrees. So this would be my F3. F3 is here, the tension. Actually, it's the tension exerted by this string. Okay, so that would be my F3. And then I have another force, F2, and F2 is perpendicular to this side here. Okay. So now F1 is just again, if I gonna somehow if it's much easier for you to see, you can actually do a broken line to denote that this is my, okay, this is my y-axis, and going upward, I'm gonna use that one as positive. Downward, this is negative y, and then to the right would be my positive x. So therefore, I have this imaginary x and y axis that I'm using. So if you can see, my F2 is just lying the x-axis. However, my F3 has two components. Again, this is another way of drawing your x and y component. Well, if you can see here, my origin of my F3 is here. So if I gonna get the x component of F3, I just gonna project a line towards the x-axis. And if you can see here, this is the x component of my F3. So this is my F3x. And I can also make the y component here, but another way of looking at that one is actually, I think this is what you did in your math. To get the x and the y component, you try to project the tail of the vector towards the y-axis, and the one that hits there would be the tip of the component of that particular vector along the y-axis. So actually, this is another way of drawing your x and y component. So if you can see, this is my F3y. Okay, so if you're wondering, well, how would you create the right angle triangle? This F3y here is just parallel to this one here. So basically, if that is F3y, that also means that this is my F3y. Okay, so again, as earlier, if this is 60 degrees here, if I can extend that one, if that is 60 degrees, the other one should be 30 degrees. So that means that this angle here is 60 degrees. So the 60-degree angle is somewhere here. The angle that is located between our f3x and the vector f3. So again, that's the first thing that you need to do. You need to identify the forces first. And if you can break it down to x and y component, try to also do it in your diagram. Okay? So now, if you can see here, F1 of 50 newtons would be lying along the y. And if you can see here, the forces along the y only contains two forces. One is directed upward, right? And the other one is directed downward. So with that, without actually solving, I know that the magnitude of F3y is equivalent to 50 newtons. Again, the box doesn't move in this case. So that means that summation, again, I can also say that the net force, so if I'm taking the forces along the y, it's equal to 0, as well as the net force along x should be equal to 0. Okay, because the object does not move, that means that the net forces on both x and y axis, or the component, vertical component and horizontal component, should give me equal to 0. So I'm gonna deal first with the y components because that's the only one of the force there is given, and that is F1. So using the fact that the net force is equal to 0, that means that I should be looking at the value of F3y, or actually in this case, I will know the value of F3y. Okay, so if I'm gonna expand that one here, there are only two forces acting on my F net y. That would be F3y, and then plus negative F1, and that would give me equal to 0. And if you can see here, this would be F3y is unknown, but I have the value of F1, which is 50, so that's negative 50 is equal to 0. And that should give me the answer of, again, without necessarily solving it, I can already identify, since there are only two forces along y, and if the balance is out, that means that whatever the magnitude of this downward force should be the magnitude of the upward force. But formally, you can also do the calculation and actually see that indeed F3y is 50 newtons with the magnitude of 50 newtons, but it's upward. So that's the magnitude of your F3y. But how can we use this value to solve for F3? Well, remember that F3 is the length of this one. The magnitude of F3 is represented by the length of this. Okay? But of course, when you talk about the force itself, it should be the magnitude and the direction. But in this particular case, to solve for the magnitude of F3, okay, so solve for magnitude of F3. So in order for me to solve that, well, you go back to your trig. Okay, So I know that the value of F3Y, or this side here, is 50.0 newtons. Okay, I've given the angle of 60 degrees. One angle, one side. So therefore, I can already solve for the other sides using trig. Okay, so I can use trig. Well, if I just gonna draw that one out, this whole thing, so solving for F3, I'll just gonna redraw this one here. This is my, again, just using the right triangle from there. So if I'm gonna draw a right triangle, this is my F3. This is my F3Y, which has a value of 50 newtons. Okay, and again, I want to solve for F3 because that's one of the question. And this is 60-degree angle. So I have one angle and one side. Well, I'm gonna revisit my trig functions if this is enough. Well, this particular side is opposite, and this F3 is actually the hypotenuse. So hypotenuse, I have the angle, I have the opposite side. So is it not that using the sine function, I can solve for the hypotenuse? So again, F3 is the hypotenuse. So using the sine function, sine of 60 degrees. Sine of 60 degrees is opposite, so which is F3Y, all over the hypotenuse of F3. Again, where did I get this value? This is F3Y is the opposite side, okay? Sine is opposite over the hypotenuse. Again, that's how we define sine of an angle. It's just the ratio between the opposite side all over the hypotenuse. So again, this F3 here is the hypotenuse. So again, if you can see, that's the hypotenuse. F3 is the hypotenuse. And I want to solve for F3. So working through with this equation here, F3 is equal to F3Y all over sine 60 degrees. So therefore, the magnitude of F3 is just equal to, well, it's given 50 newtons divided by sine of 60 degrees. And the magnitude of F3 would be equal to, let's see, is it 57.7? So 57.7 newtons. That's the magnitude. But of course, if you want to get the direction, or the direction is given, you now have there 60 degrees. So if you're gonna use the north south, so north, south, west, east, so therefore you can rewrite your F3 as a vector with a magnitude of 57.7 newtons. Direction is 60 degrees north of east. Okay. So again, 57 is the magnitude. So remember that this just gives you the magnitude. But this whole thing, this is the direction. So since you want to get the forces, force is a vector quantity. So it's a vector. So it should have both magnitude. So this is the magnitude. And then the direction is the 60 degrees north of east. So again, we're able to solve for the magnitude of F3. But the next thing that we need to solve, that is just half of the problem, because we need to solve for F2 also. Okay? But F2, if you can see, F2 is just lying along the horizontal axis. Okay? Your F2 doesn't have any Y component. So F2 is just along your X axis. So therefore, if you can see here, I'll be using uh, the X component because F2 is along X. So you have here this and this force. So F3X and F2. Okay. And basically from there also, I can right away say that the magnitude of my F2 is the same thing as the magnitude of my F3X. Okay. Because again, their forces are opposite in direction, but there are only two forces along X. Again, it should be that these two forces are equivalent because you have, again, F2 plus the negative of F3X equal to 0. So therefore, the magnitude of F2 is just equivalent to the magnitude of your F3X. So the magnitude of both F2 and the X component of your F3 should be equal. So now you just have to know what would be your F3X. What is the value of your F3X? Well, given the value of your F3, remember that the magnitude of your F3 is given by this one here. This is the magnitude. This is the magnitude of your F3. This is the magnitude of your F3. And if you can see in this triangle, going back to the triangle, this is just your F3X here. And based on the angle, this would be your adjacent side. So F3X is the adjacent side of that 60-degree angle. So if you're going to expand your F3X, that is just equivalent to F3 cosine of 60 degrees. So again, how did I get that one? Well, that is the adjacent side. F3X is just the adjacent side. That's why I'm using cosine. Okay. So F3 cosine 60 degrees. And now I already know what's the value of my F3. So therefore that would be 57.7 cosine of 60 degrees. So the magnitude of my F2 would be equivalent to the value, whatever the value that it will give me. So that would be around 28.9 newtons. Or again, final answer would be 28.9 newtons. Direction is west. Okay, so that would be your final answer, both the magnitude and direction. Okay, any question with this one? Anyone? Again, in some of the question, it will not ask for the magnitude and direction. It will just tell you the quantity. But the quantity of force, again, is a vector quantity. So just don't forget to supply also its direction. Okay. So again, commonly we just use the simple Cartesian coordinate system, positive y upward, up, down, left, right, or we can also use north, south, west, east. So any questions with this one here? So again, the key thing is knowing the free body diagram. It should be. It becomes easier if you have set up your free body diagram correctly. However, if somehow you missed something here, that would be also, again, part of your answer is the correct free body diagram. If you messed up with your free body diagram, there's a big chance that you will also get a wrong answer. And if you have noticed, we went back to your trig. So you still have to familiarize that. Again, you're just creating right triangles here. Again, if we are talking about x and y component, always go back to your trig ratios. Again, because the x and the y will always be perpendicular to each other. Okay, the x and the y component is 90 degrees apart. If you can see here, this is 90 degrees. That's always the case. Okay, so hopefully this is kind of clear with you, like expanding things, like from here to here. And actually, you can see that one if you have uh, drawn your free body diagram. If you can see here, these are my y component. Again, it's not always that you only have two. It could be three. It could be more than that. The forces acting along the y as well as the forces along the x. But then again, you can see that if you have drawn your free body diagram. So again, make it a practice. If you're answering dynamics problem, it should be drawn, or part of your solution should be the free body diagram. Okay, so if there's no question with example number 3, we can proceed with the next examples. This time, acceleration problems. So if you have acceleration, well, the one that is uh, applied here is the second Newton's law. That if an object accelerates, there must be net force is not equal to 0. Okay? And the net force is just equivalent to the product of the mass of the object times its acceleration. Okay? So F net does not equal to 0. So that is very important in this case. It's not equal to 0 because A is also not equal to 0. Okay, acceleration is not 0. So, so in this case, uh, the object should be moving. Okay, because object is not in constant speed but changing direction. Well, that's what happens in a circular motion. In a circular motion, even though the speed is constant, you can have that one. However, since the direction is constantly changing, the acceleration is not constant there. You have non-zero acceleration. Okay. So again, net force is equal to 0 is given by this, but that is just the same thing as net force can be expanded by the individual forces equal to that, or if I can extend in terms of x and y, so that means that the forces F net along x is just equivalent to the mass times acceleration along x, or also have that the net force along the y is equal to the mass of the object times that's the acceleration along y. So yes, so it should be, again, if you have two dimensions, the dimensional forces, might as well break it down first to its x and y. But in most cases, though, the acceleration is just in a single axis, or even in the inclined planes, like if the surface is angled off from a horizontal, so you have a particular angle, it's inclined, but still you can break it down to maybe down the incline, or you have perpendicular, parallel or perpendicular. Mostly the motion is just along in a single axis. However, for two-dimensional motion, just in case, or two-dimensional forces, you can break it down also to net force along x and then the net force along y. Although in most cases, one could be 0, the other one has acceleration. So that means that the object is just accelerating along the x-axis. Net force along y is 0. That means that you don't have any movement along the y-axis. So just like in this case here, like example number 4. Marlo is pushing a 35 crate. Marlo applies a force of 100 newtons to the right, and 75.0 newton frictional force opposes Marlo. Determine the acceleration of the crate. So maybe perhaps it's kind of obvious upon looking at just the numbers there. However, again, make sure that you draw the free body diagram. So the free body diagram will tell you the different forces acting on the object. So the object is acted upon by what forces? Well, you have there, one is the applied force by Marlo. It's to the right. So I call this one FA. And then the magnitude is 100 newtons. And by the way, I should just place there a dot to indicate that it has three significant digits. And you have frictional force to the left. Okay, this is FF 75.0 newtons. And even though the movement is just either left or right in this case, that means that you're just using the x-axis. However, just to formalize, or just to formalize all the forces acting on this object, I know that this is also Fg, okay, and the normal force. It's just that in this particular case, these two forces are equal. So if they are equal, that means that acceleration along the y, so acceleration along the y is 0. So therefore, the movement is just along the x. So in this case, so again, there are two in totality. The crate is acted upon by 4 forces, but the one that the motion of the object is just along the x, because if you can see, the normal force in this case is equal to the weight of the object. So essentially, the force or the acceleration in this case is just along the the x-axis. Okay, so the mass of the crate is 35.0 kilogram. Again, you have two forces. You want to solve for the acceleration. So I know that there should be an unbalanced force from the free body diagram itself. So that means that the net force here is equal to MA. So there are two forces, FA plus the negative of the friction, magnitude, whatever is the value of the friction, is equal to mass times acceleration. So FA here is 100 newtons plus the negative of 75 is equal to 35A. So this is 25 point zero. Okay, 25 okay, 25 is equal to 35A, and then you divide both sides by 35, divide by 35. So A is equal to, well, A is a positive number, so that means that the acceleration should be in the positive direction. That should be around 0.714 meters per second squared, and the direction is to the right. Okay, remember that second Newton's law tells you that the direction of the acceleration, okay, second Newton's law tells you that direction of acceleration is the same as direction of net force, and vice versa. So if you know the direction of the acceleration, you'll also know that the direction of the net force would be the same as that. So remember that since the net force, you can see again, that's kind of obvious already from the free body diagram of you that this will be moving to the right. So the net force is to the right. That means that the acceleration is also to the right. So, but then again, still have, this is a simplified version where only you have two forces, but this could be more complicated. Like you can have more forces maybe going to the left, or more forces that is going to the right direction. But still, you still use the same thing, taking the sum. Okay, so you just go back to essentially what does it mean if you're gonna take the sum of the forces. Well, it's just taking the algebraic sum. Okay, in this case, even though you have vertical forces, but if you can see in this particular case, the vertical forces, the normal force and Fg would just be equivalent. So therefore, the acceleration there, or the vertical acceleration, is just equal to 0. Okay. Okay, let's do example number 5. Example number 5. You have here I think this is 1,000 kilogram elevator is being raised by a cable that exerts 2.7 times 10 to the power of 4. It's around 27,000 Newton upward force. At the same time, it experiences a 2.5 times 10 to the power of 4 Newton force of gravity. What is the acceleration of the elevator? Okay. So again, always start with the free body diagram. But in this case, the free body diagram is the elevator. So therefore, you're gonna be checking elevator. So again, you don't have to draw the elevator. You can just represent the elevator as a dot. Okay. And now, from the given problem, you try to examine what are the forces acting on the elevator. So you have here one exerts a force, upward force by the cable. Actually, this is the tension of the cable. So it's an upward force. So that means that you have F upward. I just call that one as Ft. That's again 2.7 times 10 to the power of 4 times 10 to the power of 4 Newton. And at the same time, it experiences force of gravity of 2.5 times 10 to the power of 4. Okay. So we know that gravity is always directed downward, so there must be a downward force. And this is Fg, which is equivalent to 2.5 times 10 to the power of 4. Okay. Power of 4 Newton. Question is, what would be the acceleration? So if I'm gonna take note of the things that I know, given the mass, which is 1.00 times 10 to the power of 3 kilograms, and then I want to get the acceleration. So if you can see here, from the free body diagram itself, you can already identify that this object must be, or the elevator would be accelerating upward. So the acceleration would be upward. So the acceleration here would be upward. Again, how do I know that? Well, the force going up is bigger than the force going down. So this object must be accelerating upward. Okay, so for my solution here, I'll be using, again, the forces is only along the vertical components. So I don't have to place that I'm talking about the Y component. I'll just say that I'm taking the net force on the elevator, and that is equivalent to its mass times its acceleration, or the acceleration is just F net all over the mass. So if I'm gonna substitute everything up, this is 2.7 times 10 to the power of 4, then minus 2.5 times 10 to the power of 4, then the mass is 1.000 times 10 to the power of 3. So everything is given, the force is in Newton, the mass is in kilograms. Automatically, I would say that the acceleration would be in meters per second. Okay, so this would give me an answer of 2.0 times, no, it should just be exactly 2.0, and then the direction is up. Okay, so acceleration, again, acceleration is a vector quantity, so vector. So answer should have magnitude as well as direction. And again, right away, I would say that it's upward because of the net force would be bigger in the upward direction. Okay. So any question with this one here? Kind of straightforward for now. Again, you only had two forces here, but it could be more than that. Okay. Well, example number 6. Let's take example number 6. Um, a 1,200 kilogram elevator rises at 2.4 meters per second. What is the force exerted by the elevator? So exerted by the elevator cable. Well, actually, this is just the same thing as the previous one. The only thing is you're given the acceleration. Okay. So again, I'm gonna draw the free body diagram of the elevator. Oh, so I'm gonna identify what are the forces acting on the elevator. I have Fg. Remember, the weight of the elevator is given by mg. So I'm not given that particular value, but I can solve it using 1,200 multiplied by 9.8. So 1,200 times 9.8. That's around 11,760 newtons. Well, I'll not be rounding up for now because this is not my final answer. So the cable would be the one that will lift it up. Okay, so this would be Ft. And this is a question mark. That is the main question in this particular problem. But you're given that the acceleration would be equal to 2.4 meters per second squared up. Okay. So again, the acceleration is not equal to 0, so you'll be using the second Newton's law. So that means that net force on the object is equivalent to the mass times its acceleration. So now, if we're gonna examine what are the forces, so you have two forces, Ft going up and Fg is going down. Okay, so now if I'm gonna expand that one out, that would be Ft plus the negative of Fg is equal to Ma. Ft is the unknown, so I don't know that one, but this is plus the negative of 11760, and that is equivalent to the mass of 1,200 times 2.4. Okay, so Ft minus 11760 is equal to that would be 1,200 times 2.4. That would be 2,880. So to solve for Ft, I'm gonna add both sides by 11760, 11760. Ft would be equivalent to 11,760. It's around 640 newtons, or well, given has two significant digits, so that would be 1.5 times 10 to the power of 1, 2, 3, 4 newtons. This should be upward or up. Okay, so it also makes sense that the upward force must be greater than the weight. Otherwise, the elevator will not be moving up. This particular case, right? So the tension must be greater than the weight of the object.